So today I will be discussing about the electronic configuration of elements, how to write configuration. So everyone have some confusion related to it about configurations, how to fill the orbitals with electrons. So on what basis they are, the rules are being given. So all are not clear, although some are, most students are clear about it, because in first year only, HS first year, we learn this. So but to some extent I have seen that most of the students are not clear about it. So আজি মই সেই ইলেক্ট্ৰনিক কনফিগাৰেশ্যনবোৰ কেনেকে মানে লিখে, কেনেকে ইলেক্ট্ৰনবোৰ যিমানে উইথ এটমিক নাম্বাৰ যিমানে এটমিক নাম্বাৰ বাঢ়ি যাব, সেই এলিমেণ্টবোৰৰ ক্ষেত্ৰত আমি ইলেক্ট্ৰনবোৰ কি ৰুলত বহাম, মানে সেইটো আমি বুজিম। গতিকে ইলেক্ট্ৰনিক কনফিগাৰেশ্যনবোৰ আমি যেতিয়া লিখোঁ, যিকোনো এটা বস্তুৰ ইলেক্ট্ৰনিক কনফিগাৰেশ্যন, ইলেক্ট্ৰনিক কনফিগাৰেশ্যন লিখাৰ আগত আমাৰ কি আহে, প্ৰথমতে আমি তিনিটা থিয়ৰি পঢ়িব লাগে। সেইকেইটা হৈ গ'ল পাউলি এক্সক্লুশন প্ৰিন্সিপল, 2 নম্বৰটো হৈ গ'ল অফবাউ প্ৰিন্সিপল, and the third is your Hund's rule. So these rules or principles must be clear before writing any electronic configuration. These 3 rules are very important. So at first, Pauli exclusion principle. So yat ki hoy, ami janibo lagibo je Pauli exclusion principle er khetrot amar importance ot ahe quantum numbers. The quantum numbers mane ki, quantum numbers are those numbers which are required to explain an element completely. So the quantum numbers amar ki ase, quantum numbers. Number 1, principal quantum number. Principal quantum number. Principal quantum number, it is symbolically denoted by small m. So principal means it is the most important. So what does it signify? It signifies the number of cells present. Clear? So second is your azimuthal quantum number is small l. This small l depends on small n. So as this l depends on n, therefore it signifies number of subcells in a cell. Number of subcells in a cell. Subcells bur amar ki ki asile, S, P, D, F, G, H. These are also given, but not yet found in the elements. Number 3 is magnetic quantum number. Magnetic quantum number. Why it is given magnetic quantum number? Small m. It depends on azimuthal quantum number also. In subscript, it is the L is written. So why it is given magnetic? Because it can signify, this magnetic quantum number can give information about the magnetic characteristics of the compound, of the element, sorry. So this is denoted by ml. Number 4 is spin quantum number. Spin quantum number. So spin means electronic spin. It is given by S. So this spin means in an orbital there are electrons. So these electrons, how they spin? This spin is denoted by the spin quantum number s. Now principal quantum number values are given by n is equal to 1 depending on the number of cells, 2 cells, 3 cells, 4 cells, dot dot dot. Similarly, for azimuthal quantum number of subcells, these are given by 0 to less than n. So what does it mean? This means for n is equal to 1, L is equal to 0. It cannot be equal to n less than n, but starting from value 0. So for n is equal to 2, it will be L is equal to 0 and 1. Again see, for n is equal to 3, again 0, 1, 2. For n is equal to 4, L is equal to 0, 1, 2, 3. Now see, azimuthal quantum number L. These values signify what? Number of subcells in a cell. Subcells means SPDF. Now these values can denote how many subcells is present in these cells. So for one cell, first cell, this K cell, what we learn in from class 10, we are learning about these cells K, L, and M. So for this L equal to 0 means this is S subcell. Hence we can conclude that for S subcell L value is 0. Similarly, L is equal to 0 and 1 for N is equal to 2. So L is equal to 0 for S subcell. Therefore 1 is for P subcell. Hence in the second cell we have two subcells. 0 is for S, 1 is for P. Similarly, 0 is for S for n is equal to 3, 1 is for P, 2 is for D. Hence, in the third cell, there are 3 subcells S, P, D. Similarly, in the fourth cell, we have 4 subcells S, P, D, and F. So, we can conclude that for S subcell, L is equal to 0, P subcell, L is equal to 1, D subcell L is equal to 2, F subcell L is equal to 3. Done. So we have now learned about the values of L corresponding to the respective subcells. It is clear now. Now azimuthal quantum number we have learned. Now magnetic quantum number values are given by plus minus L. Means for L is equal to 0, M is equal to 0 because plus 0 minus 0 is same. L is equal to 1, M is equal to plus minus 1 means minus 1, 0, plus 1. L is equal to 2 means M is equal to minus 2, minus 1, 0, plus 1, plus 2. L is equal to 3 means M is equal to minus 3, minus 2, minus 1, 0, plus 1, plus 2, plus 3. Now, similar as we learned about for n is equal to 1, L is equal to 0, corresponding to n there are values of L. Similarly, for values of L there are values of M. So, we now learn it one by one. For L is equal to 0, it is S subcell. What does M value signify? Orbitals. So, in S subcell, how many orbitals are there? Since there is only one value, so in S subcell, one orbital is present. Okay, so we give one orbital in case of S subcells. Similarly, for n L is equal to 1, this is P. So P, in P subcell there are 3 orbitals respective to 3 values. Similarly, for 2 means it is D. So in D subcell there are 1, 2, 3, 4, 5 orbitals. Similarly, for L is equal to 3, there are 1, 2, 3, 4, 5, 6, 7 orbitals. Done. So in this way, magnetic quantum number gives or signifies how many orbitals are present in a particular subcell. So in S subcell there is 1 orbital, P is 2, 3 orbitals, in D there are 5 orbitals, in F there are 7 orbitals. Next is your spin quantum number given by S. Spin quantum number is dependent on M. Magnetic quantum number means every orbital have 2 spins, plus half, plus minus half means plus half and minus half. If 2 spins of electrons are there, that means one orbital must contain 2 electrons. Hence, every orbital there are always maximum of 2 electrons. So, if I give you this P3 p orbitals, means in P there are 3 orbitals, so every orbital should contain maximum of 2 electrons. It cannot contain 3. This will be wrong. So maximum it will contain 3. One will be upside plus spin, one will be downside to maintain the stability. So NLMS, this quantum number signifies how an atom or element have its arrangement of electrons and in its orbitals in a particular subcell of a particular cell is arranged. The arrangement is given. So complete data of the element can be known if we know about these quantum numbers. So we have learned about it. Now, what does the Pauli exclusion principle says? The Pauli exclusion principle says that no two electrons in an atom can have the same set of 4 quantum numbers. 2 electrons, if we consider an element or atom, and if we consider any 2 electrons, then if we count their quantum number values n, l, m and s, so that these 2 electrons may have same value of m, same value of l, same value of m, but different value of s, means one will be plus, one will be minus. Again, say if we consider an electron, these 2 electrons which have same as value, that means their s values are same. This is present in the same subcell, l value same. If l value same, then n value also same. But what it gives, this is minus 1, this is 0, this is plus 1, means their m values are different. So if any 2 electrons of an element or an atom is taken, they cannot have, or it is not possible that they will have any 2 numbers with any 2 quantum numbers with the same value. So this is what the Pauli exclusion principle says. So I guess it is clear. So another is, second is your Aufbau principle. The Aufbau principle says that electrons enters the orbitals in the increasing order of their energies. So with increasing energies means from lower energy to higher energies of orbitals, electrons are being filled in case of an element, and in this way we write electronic configuration. So for energy selection or to know the order of energies, above gave a rule and a drawing. So how you can know about the energies. So everybody can write from it and remember. And if you keep on practicing it, it will be easy. So in this way, above gave the increasing order of energies of orbitals. So first 1s is the lowest energy, so electrons will fill first here. Then comes the 2s, then comes from this end 2p, then 3s, then again 3p, then not 3d, 4s in order of increasing energy. Then 3d, then comes 4p, then 5s, then 4d, then 5p, then 6s, then 4f, then 5d, then 6p, then 7s. So it is important that up to 7s you are aware of it, about the energies. So let's say now sodium atomic number all we know 11. So 11, how these 11 electrons will be added to the orbitals. So following the above principle. So first, as one s orbital contains one subshell, one orbital. So one orbital contains maximum of 2 electrons. So first 2 electrons goes to the 1s orbital of the s subshell. Next is 2s, 2, 4 electrons are occupied. Then comes the energy of 2p. In p there are 3 orbitals and maximum of 2 electrons in one can have a maximum of 6 electrons. So 11 are occupied. After 2p there comes 3s. So only 1 electron is left out of 11. So 3s will have 1 electron. Okay. So in this way the electronic configurations are written. Now the third rule is, number 3 is Hund's rule. Hund's rule is given on the basis of occupancy of electrons in orbitals. How you fill orbitals the way. The Hund's rule says that, let's say this is a p orbital. So this orbital contains 3 electrons. So if you now start to fill these p orbitals, then you cannot fill 1, 2, 3. You cannot fill because this will create imbalance or instability. So for this you have to fill it one by one. That means Hund's rule says that for before filling an electronic orbitals, you have to remember that you have to fill every orbital with 1 electron minimum first. Then you can only pair it. So this electron will come here in this way. First p3 will be filled, then after this if p4 is given, then this. In this way, electrons are filled in orbitals. First, every orbital should be half filled, one electron each. Then it will be paired. Similarly, for D, say first D5, you cannot fill 1, 2, 3, 4, 5 because this will be vacant and this will create imbalance. So you have to fill it one by one. 1, 2, 3, 4, 5 in this way. And after this, if D6, D7 comes, then fill it again and pair these orbitals. So these are the rules or principles you have to remember before writing any electronic configuration. And if these principles thoroughly your concept and your everything is clear about these three principles, then you can write any type of electronic configuration up to say 118 elements. But some are exceptional. Some have exceptional qualities, such as for stability they are changing their rules. So this will I will tell this in some other classes. So first of all, revise this all, remember this, and try to follow this by practicing to write the electronic configuration some elements. So I can give you some homework so that you can try. Let's say scandium, let's say potassium, okay, let's say chromium, let's say aluminium, and the last, say iron. In this 5 you all try, and if any exception you have seen from your own side, then tell me in the comment section, and after that I will explain about the exceptions and further section. So for this time, this is it. Thank you.